All right. Good morning again. Um, I mean, there might be the odd other question. I don't want to, quash you here and say we're not going to go over anything. We want to kind of keep this to a fairly tight schedule today, though. So, any other questions? And again, if you have them, please ask. I just may not go over them in extensive detail. Go ahead, Jason. 7b. Morning. So we have tan squared minus tan theta minus 2. And again, I'm going to challenge you here that when we factor this, we don't have to write this as a squared, etc. One thing that might help, though, Jason and everybody, is sometimes just this tiny little shift in how you write it makes more sense to people. Most people probably understand that tan squared of theta means tan of theta quantity squared. But now what you're looking at is something where the quadratic term has a coefficient of 1, which means if this is factorable, it's simply a matter of writing what is being squared to give you the first term, of writing that, which is tan of theta, in the first available opening of each binomial. And then you're looking for two numbers which multiply to give -2, and those same two numbers add to give -1, because -1 is the coefficient of the middle term. So there's only two numbers, disregarding positives and negatives. There's only two numbers that multiply to give 2 and 1. They're 2 and 1. And it doesn't really matter where I put them because each one has tan. I want these two numbers, though, to add. I want them to multiply to give negative. So one's going to be positive, one's going to be negative. And I want them to add to give -1, which would mean we would be dealing with this situation where the 2 is negative. Don't forget that this is 0. This is equal to 0. And that leads you to tan of theta plus 1 equals 0 and tan of theta minus 2 equals 0. I'm guessing that it says in this question something like to the nearest 10th. Because I know that when I see tangent of theta equals 2, I mean, I just happen to know from experience that's not going to be a multiple of 30 degrees or 60 degrees. It's not a nice angle. This one, on the other hand, in fact, we talked about this one in the seminar this morning, didn't we? It's the 45-degree locations in quadrant 2 and 4. This, you're going to have to use your calculator to find a reference angle. So can somebody help me out here? And I don't know, let's look at the question. Did we want degrees? We did, in fact, want degrees, so we would be in degrees, definitely. If we wanted radians, since we want decimals, we'd be in, yeah. Sorry? 63.4. So 63.4 degrees. Tangent is positive, and tangent is positive in quadrant 1. So you would put 63.4 degrees there. In quadrant 3, you would put the 63.4 degrees there. I'm just writing 63. Over here, if you use the same approach, you would get a reference angle of 45 degrees, but it would be in quadrant 2 and quadrant 4. And then, of course, what you're after here, everybody, are these angles. which you have to now calculate based on knowing that, for example, this is 180 degrees right to the end, so we're going to subtract 45. This would be 360 minus 45. This one's just 63. This one would be 180 plus 63. Is that okay, Jason? Okay. So again, I do want to move on now. It's not that this is a long lesson. It can be if we really drag it out, but I would rather just get to the point of today's lesson so that you can get some practice with the material. We're all of a sudden jumping into chapter 5. And it's just the way that I've decided to split up the 3 chapters on trigonometry into 2 units. 3 chapters is just too much, so chapter 5 it's going to flow better if we go from chapter 5 to 6 as we pass from one unit to the next. So we are looking at section, this actually should say on your handout 5.1, 5.3, correct? Okay. 5.3 deals with tangent, 5.1 deals with sine and cosine, and we're going to learn about 5.3 just in passing. It's really not that big of a deal. So we're going to be looking at the graphs of the 3 primary trigonometric functions. We're going to be looking at the graph of y equals sine of x, y equals cos of x, and y equals tan of x. And as familiar as you are with something like y equals x squared, you know what y equals x squared looks like. You now have the added burden of having to know what y equals sine of x looks like, and what y equals cos of x looks like, and what y equals tan of x looks like. And if you know or expected to know what they look like, then you were expected to know all of the properties of them. So to begin with, this is the graph of y equals sine of x. And this is not a memorization thing. It's something that you should be able to understand where it comes from. Because, first of all, x on this graph is an angle. It's a rotation angle. So when you look at a rotation angle of 0 degrees, if I were to go to the unit circle, as wobbly as that looks, 0 degrees is here, and the sine of 0 degrees is 0, because it's the y coordinate on the unit circle. If you were to look at pi over 2 rads, or 90 degrees, at pi over 2, the y coordinate on the unit circle, which is the sine of the rotation angle, is 1. And then it starts falling off again. And when we get to 180 degrees or pi radians, the y coordinate is back to 0. So the y coordinate goes from 0, it goes from 0 to 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.91, and then it starts going back down to 0. So we're tracing the y coordinate. But then the y coordinate becomes negative. And it gets more and more negative until it becomes -1, and then it starts increasing back again to 0. And that's why this graph starts here, peaks at 1 when x is pi over 2, because that corresponds to the top of the unit circle. And then by the time we get to pi radians, we're on the left side of the unit circle where the y coordinate is 0. And I'm focusing everybody, this is going to be confusing at times. I'm focusing on the y coordinate because it's sine, not because this is y. It's because it's sine. And then when you get to the bottom of the unit circle, which is at 3 pi over 2, which is here, the y coordinate on the unit circle, which is the sine of the rotation angle, is -1. And then as you make your way all the way from 3 pi over 2 back up, or back to 2 pi, or back to the beginning, the y coordinate increases. And what I would try to impress on you is this. When you are looking at drawing these, that wave, that complete cycle has 4 parts. It has a part that goes up. That didn't work. It has a part that goes up, a second part that goes down, a third part that goes down, and a fourth part that goes up. So it's kind of up, down, up. And it's not straight lines. Okay? So now we're going to answer some questions about this. And it extends in both directions because we know about coterminality that if we go in the opposite direction, you're still going to trace out those same y coordinates on the unit circle. So what are the properties of this? Well, what's the domain and range? The domain is x is any real number. And what's the meaning behind this? The meaning is that you can take the sine of any angle. We could go all the way down to x equals 1,000,000 radians or 10 gajillion degrees. You still can take the sine of it because it's going to be located someplace on the unit circle. The range is -1 is less than or equal to y, which is less than or equal to 1. There's another way that we could write this that is maybe, well, it's probably going to be new to you. It's to say -1 is less than or equal to sine of x, which is less than or equal to 1. And that may seem confusing because I'm saying the range has an x in it, but sine of x is y. I'm just saying sine of x is between -1 and 1. What are the intercepts? Well, if you stop and think about the intercepts, that would be where sine of x is 0. And that's these two locations on the unit circle at 0 and pi. But 0 and pi would give you a sine of 0, and so would 2 pi and 4 pi and 6 pi and -8 pi and 11 pi. And you can see that visually on the graph. Let me get rid of this. You can see that visually on the graph that the x-intercepts are at 0 pi, 2 pi, -pi, -2 pi, -3 pi. They are at multiples of pi. We cannot write every x-intercept. So what we have to do here is say the x-intercepts are equal to n pi, where n is an integer. Is there a maximum and minimum value? Yes. The maximum value of sine of x, or the maximum value of y, is 1. The minimum value of sine of x or y is -1. Well, I don't know about obviously, because look at the range. -1 to 1 for y. The minimum is -1, the maximum is 1. We introduce now two new terms. One of them is period, and for those of you that have taken Physics 20, the period here is the same as the period for simple harmonic motion, or the period of a pendulum, or the period of a mass on a spring. In Physics 20, and I know not all of you have taken that, but in Physics 20, the period, which is also given the symbol k in physics, is the time it takes to do the whole thing once, one complete oscillation. Well, that means the period here corresponds to the kind of time, in air quotes, that it takes to go through one complete cycle. The time, which is a horizontal kind of thing, it takes to go up, down, up. The time it takes to repeat. Well, think about this. As you get that point moving around on the unit circle, it has to go around a full revolution before it repeats. So the period must be 2 pi. And you can see that. If I look at this graph, this thing in green that I've drawn is one complete cycle. So it repeats there over 2 pi. Let me fix that a bit. It will repeat here over another 2 pi. The distance it takes to do the up, down, up is 2 pi. The other term is amplitude. Amplitude of, and this is the same as the amplitude in Physics 20 of a wave. Amplitude of a periodic function like this is how far it is from the middle vertical location to the top or to the bottom. And you can see on the graph that corresponds to this. That's called the amplitude, and the amplitude is 1. we don't say it's -1, we just say it's the distance. How far is it from the middle of the graph to the top or to the bottom? So the amplitude is 1. Capiche? Well, this is what cosine of x looks like. Now, this is a little more confusing for me to explain. But again, the confusion arises because x on this graph is not x on the unit circle. It's the angle on the unit circle that you're rotating through. Y on this graph is the x coordinate on the unit circle, because y is cosine of the rotating angle. But anyway, let's talk about the unit circle. When you have a location of 0 radians or degrees, the x coordinate on the unit circle is 1. The cosine of 0 is 1. And that's why this graph starts at the top. When you rotate to the top of the unit circle by rotating through a rotation angle of pi over 2, when you're at that location at the top of the unit circle, the x coordinate on the unit circle is 0, which means cosine of the rotation angle is 0. And then this continues to go all the way to pi. The x coordinate is -1, which means cosine is -1. Go back to 2 pi or back to the beginning, you're back to 1. There's still, everybody, 4 pieces here. 1, 2, 3, 4. That shape that I've highlighted is still one complete cycle. Is it the case that this is also a complete cycle? Sure. It's got the 4 pieces to it. The red one goes up, down, down, up. But I want you to notice the distance from here to here is the same as the distance from here to here. Okay, so let's answer these questions. What's the domain and range? Well, the domain is x. The rotation angle is any real number. The range is -1 is less than or equal to y, which is less than or equal to 1. And again, you could write -1 is less than or equal to cosine of x, which is less than or equal to 1. The x-intercepts, this is a little trickier. The first x-intercept is at pi over 2. Let me clean this up. The first x-intercept is at pi over 2. And the distance from pi over 2 to 3 pi over 2, which is the next x-intercept, is pi. And the distance from pi over 2 to negative pi over 2 is pi. So the x-intercepts are still separated by pi, just like with sine of x, but the first x-intercept is not at the origin. It's at pi over 2. So what we have to do for the x-intercepts here is say the x-intercepts are pi over 2 plus multiples of pi. What's the maximum and minimum value? Well, y max is 1. Y min is -1. What's the period? How long does it take to start repeating? 2 pi. Because, when you compare these graphs in terms of obtaining them from the unit circle has a full revolution of 2 pi. Well, any circle does. So wherever you start, once you get back to that place, you're going to start repeating the same set of numbers. So the period is still going to be 2 pi. The amplitude is 1. You can see that the amplitude is 1. Right? It's the distance from the middle to the top. Now, before we look at tangent, and I'll be honest, I'm going through a struggle here in my mind. I haven't decided whether we're actually going to do tangent today. We might just kick it over the boards for some other time. Okay? But before we go over tangent, I want you to understand that if you ever want to see the properties of these graphs, you do have a graphing calculator. But it's important that you follow the following procedure when you graph it. So I want you, without regard to the mode you're in, I don't even want you to look at the mode. I want you to enter y equals sine of x. And then I want you to go zoom trig. There's actually a trig zooming here. So if I go zoom trig, this is what mine looks like. Okay? And I hope this is what all of yours looks like. Now look at your mode. My mode is degrees. How many of yours was in radians? Did your graph look any different? Not really. How many of yours was in degrees like mine? Okay. If it's in degrees, when you go zoom trig, look what the window does. The window setting goes from, I hate that it doesn't go negative 360 to 360. That really bothers me. I don't know why it goes negative 352.5, but it basically goes from negative 360 to 360 and from negative 4 to 4. Watch what happens now if I change this mode to radians and I go graph. The reason is I went zoom trig when the calculator was in degrees, so it adjusted the window settings to see things in degrees. If I want to see the graph even though I'm in radians, I have to go zoom trig. And it's going to give me the same picture. But the calculator looks at my mode and says, oh, this guy's in radians, I better adjust the window settings to go radians. And it basically goes from negative 2 pi, not quite, negative 2 pi is negative 6.28 to 2 pi. But the bigger picture is this, and by the way, I would want to, for the purposes of my discussion here, I would want to be in degrees. Okay? Because if you want to know the properties of sine of x and you forget, there it is. Here's a neat little trick too. You can go to your table setup, start at 0 and go up by 15 degrees. Why? Because multiples of 15 will hit 30, 45, 60, 90. They'll hit all of those special angles. So you could go to your table right now and trace all of the y coordinates on the unit circle as you rotate around it. If you ever want to know what y equals cos of x looks like, because in the pressure of an exam you forget, use your graphing calculator. And I have made a decision. We're just going to skip over tangent for now. Okay, this is what tangent looks like. We'll talk about it later. Maybe before the unit exam, or I might push this into a little 5-10 minute lesson in the next unit. But I'm not going to worry about it right now, okay? So we are going to look at the examples. And we're trying to learn something from these examples. We're trying to learn a general rule for how we determine things like range, period, amplitude, domain. Use your knowledge of transformations to sketch the following functions. Okay, y equals 2 cos of x. So y equals 2 cos of x is a transformation from f of x equals cos of x to g of x equals 2 f of x. I mean, how many of you saw that we're vertically stretching this by a factor of 2 just by looking at 2 cos of x? Cos of x becomes 2 cos of x. That means we're multiplying the old function by 2. In other words, from a unit 1 standpoint, a is 2, which means there's a vertical stretch by a factor of 2. So what is it going to look like? Well, let me draw y equals cos of x in green. Y equals cos of x starts at 1 and it's going to go through 1, 2, 3, 4 pieces in a full 2 pi. Cos of x starts at the top and goes down, down, up, up. And all I'm doing is I'm remembering that this is the maximum value of cosine, this is the minimum value of cosine, and this is the middle value of cosine. And I have to end up back at the beginning, meaning back at 1, at 2 pi. So visually what I do, and I know that many of you don't need this, but visually what I do is I take this distance and I split it into 4 chunks. Because the graph has 4 pieces to it. And in the case of cosine, it has to go down in this piece to the middle, and then continue down in this piece to the bottom, and then it has to go up to this point and up to there. And again, it's not just a straight line. You have to kind of curve things. And if your graph doesn't come out perfect, that's fine. By the way, this is just cos x. This isn't even the question, right? And we could extend it in the other direction, but I really don't care. What does 2 cos x look like? Well, 2 cos x means every y coordinate is going to be multiplied by a factor of 2. But x-intercepts will be invariant because they're not above or below the x-axis, so they don't get stretched away from the x-axis either above or below. So what 2 cos of x will look like is this. Down, down, curving up, curving up. And we could certainly continue this in the other direction. 2 pi is here. It has to, and again, I'm splitting this up visually into 4 pieces. It has to reach the middle, reach the bottom. So now I'm looking at max, min, middle. I'm not looking at 1 and 1. It has to reach the bottom, then it has to reach the middle again. Then it has to reach the middle again, then it has to reach the top. So it would look like this in the other direction, and if you really want to impress people, you put arrows on both ends and you're done. But I want us to graduate to the point, just help me out here because I didn't copy this. That little box on the bottom of your example, does it say domain, range, amplitude, period, in that order? Okay, so the domain would be x is any real number. I don't think we need to look at a graph to know the domain is any real number. I don't. I'm going to skip the range and go to the amplitude. I also don't believe that you really need to look at the graph to know the amplitude is 2. Because the amplitude of cosine of x is a vertical distance from the middle to the top. And 2 cos of x is stretching it by a factor of 2. The period is still 2 pi. And what will the range be? It will be negative 2 is less than or equal to y, which is less than or equal to 2. I'll throw this out here, and I'm going to ask you to think about it. But that corresponds to the negative of the amplitude is less than or equal to y, which is less than or equal to the amplitude. And that will always be the case unless, which we will next week, we take that thing and shift it up or down. That's going to change things. But if all you're talking about is a vertical stretch, that's the case. Any questions with the first one? Okay. Y equals negative 3 sine of x. So this is a equals negative 3, which means we are going to take sine of x, which I'm going to put in green. Sine of x starts here at the origin. It goes through 4 pieces all the way to 2 pi, which means it has to peak halfway between 0 and pi, hit the x-axis at pi, valley halfway between pi and 2 pi. This is what sine of x looks like. What does the negative 3 do to that? Well, it's going to reflect it and stretch things vertically by a factor of 3, which means that this point, and this point will not change. They're invariant because they're on the line of reflection, line of stretch. But this point that has a maximum value of 1, I'm talking right now, everybody, if you're watching on video about this point, it's going to be reflected down to negative 1, but it's also going to be stretched by a factor of 3, so it's going to go down to negative 3. What I do here when I draw these, everybody, is I say the following. And if this doesn't do it for you, then don't do it. If I stretch this vertically by a factor of 3, irregardless, turned into my dad, regardless of whether it's reflected or not, the fact of the matter is the maximum value of the function will be up here and the minimum value of the function will be down here. I mean, I flipped it over so the maxes become the mins, but those are kind of guidelines for me. And there's also a guideline in the middle. I didn't draw them exactly on the lines, but that's okay. So when I sketch this, I can easily say, well, you go down, up. Now I have to go up and then down. So this is what it looks like. And if you want to reproduce that to the left, and if you want to extend it, you can. But that's not the important part of this. You know, what this would look like over here would be. See, these guidelines are really helpful for me to sketch this. It would look something like that with arrows on each end. But what is the domain? Range. Domain is any real number. Range, negative 3, is less than or equal to y, which is less than or equal to 3. Amplitude is 3. I want you to notice that the amplitude is not A, it's the absolute value of A. And there's a difference between capital A and little a. Capital A is the amplitude. Little a is the number that's in front of cosine or sine of x. Would this work? Amplitude is the absolute value of A. Would that have worked here? Yes, because 2 is little a, the absolute value of 2 is still 2. And the period is 2 pi. Any questions with that one? All right, what about 1/3? Well, you know, let's just go off the beaten path here. We don't have to stick to the script. Let's see if we can predict what the period, amplitude, domain, and range are. Then we can look at a graph if we like. The amplitude or the domain should be any real number, right? You can take the cosine or the sine of anything. Can somebody explain why I know the period of this graph will be 2 pi? Or better yet, maybe, explain to me why the period doesn't change, because it will in some cases. Farhan? Right. A, that's the only parameter that's been introduced here that's different. A is a vertical parameter. It stretches it vertically. It doesn't do anything horizontally. The amplitude is 1/3. Because if, what are we dealing with, sine or cosine? If cosine has an upper limit of 1 and a lower limit of -1, then 1/3 of cos is stretched vertically by a factor of 1/3. It's going to be there. And that would mean that the maximum value of y would be 1/3 and the minimum would be -1/3. So what this would look like, it's cosine. Here's what cosine of x looks like. That's cosine of x, but it's stretched vertically by a factor of 1/3. So this graph all of these y coordinates will be 1/3 as great. And you can use your graphing calculator, not right now, but if you want to, you can use your graphing calculator to confirm this. Quite frankly, I think we've done enough vertical stretches that you should understand this is the case. If you did want to extend it in the opposite direction, would look like that. Again, you could go to a graphing calculator to answer certain questions for an exam, but the questions may be designed in such a way that that becomes difficult. Okay. Questions with C? So then let me throw this out to you for D. You should know that sine starts at the origin and goes up, right? That's a really important feature of sine. It starts at the origin on its way up. Cosine starts at 1 on its way down. If the value of A is 1/2, then what that means is rather than having a maximum of 1 and a minimum of -1, this will have a minimum of -1/2 and a maximum, if I can get this to go, and a maximum of 1/2. So it's still going to start here. It's still going to end at 2 pi. It's still going to be back on the x-axis halfway in between. And at the max in the first quarter, or at the end of the first quarter, and the min at the end of the third, this is what it looks like. You can write down the following domain. X is any real number if you haven't done so already. Range would be -1/2 is less than or equal to y, which is less than or equal to 1/2. I hope you see a recurring pattern throughout A, B, C, and D. You're looking at A and you're answering the question. So the range is -1/2 is less than or equal to y, which is less than or equal to 1/2. The amplitude is 1/2, and the period is 2 pi. So now we have a B value. I hope you recognize that what we're talking about here is B equals 2, which means there is a horizontal stretch by a factor of 1/2. So I want you just to think very carefully about what I'm going to tell you here. If sine of x, which I'm going to draw in green, if sine of x goes through one complete cycle in 2 pi, and I take that, and by the way, this point on a horizontal stretch will be invariant because it's on the y-axis. I take that and I put my hand right here and push it so that I compress the thing or stretch it by a factor of 1/2. What will the period be? How long will it take to repeat that cycle? Well, yeah, sorry, pi. It'll be half as great. So what this graph is going to look like is it's going to repeat from 0 to pi. And visually, that means I'm going to take this, I'm going to split it into 4 equal chunks. Splitting it into 2 is easy. Now I've got to deal with splitting these 3 pieces, 1, 2, 3 in half, and that's right here and here. So I have to go up to the top, down to the middle, down to the bottom, up to the middle. And how many of those you draw, I'm not really happy with my drawing here for the third part. I'm going to clean it up a bit. How many of these you draw is up to you. You could repeat the process. In either direction. What's the only thing that's changed here? The period. The amplitude is still 1. The range is still -1 to 1. The domain is still any real number. And I'm hoping that you're writing these things down. You're filling in that box at the bottom. That the domain is X is an element of all real numbers. The range is -1 to 1. You can still see that the minimum value, these are not asymptotes, by the way, they're just guidelines for me. The minimum value is 1, the maximum value is 1, so that determines your range. The amplitude is still 1, but the period is half as great. I want you to notice that the period is 2 pi, which is the period of sine of x, divided by b, which is 2. If you take 2 pi and you divide it by 2, the 2's cancel, you're left with pi. Let's try this one. Cos of 3x. Well, that's going to stretch things horizontally by a factor of 1/3, which means here's cos in green. Down in the first quarter, down in the second quarter, up to the axis in the third quarter, up to the maximum in the fourth quarter. There's cos of x, a little caffeinated jiggle there in the middle, but you get the idea. 1/3 means it's going to repeat 1/3 as frequently for b. b is 3, so it stretches horizontally by 1/3. I wouldn't worry about taking 2 pi divided by 3. Let's just count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 squares, right? So it's going to repeat every 4 squares. Because we're compressing it by a factor of 1/3 horizontally. So it's going to start here, end here, and my 4 kind of sections look like that. So in the very middle, it has to end up at the bottom. After the first quarter, it ends up on the axis, and then it ends up on the axis here as well. So this is it's going to repeat over and over and over again. X is any real number, right? Y, -1 to 1. Amplitude is 1. The period is from here to here. Now, I want you to pay careful attention to this because I want to show you something and then say we don't have to worry about it. When you look at this distance from here to here, this is pi. And when you break this up into 3 pieces, that would mean this is pi over 3, 2 pi over 3. So we can look at the graph and see that this is 2 pi over 3, which means the period is 2 pi over 3. But we don't have to do that. I'll get to your question in a second, Jason. We don't have to do that. The period is 2 pi over b. It's going to work out this way. If b is negative, we need absolute value signs. But if b is 3, that means the period will be 1/3 as great. So you're going to take 2 pi times 1/3. But that's 2 pi over 3. You have a question, Jason? The period on this one is simply pi. I'm going to highlight for everybody here because I had mentioned this, and I've gone a little too fast here. I had mentioned this, and then I drew over it. So this represents 1 complete cycle, so it's repeating in pi. So the period here is pi, which is 2 pi over b. In question E, yours is labeled E, isn't it? Okay. In question E, B is 2. The period is 2 pi over 2, which is pi. Is that okay? Okay. I think you know where this is going. What about if B, the parameter B, is 1/3? Well, that stretches things horizontally by a factor of 3. So if I take this thing, and I will draw it, here's sine of x. Oh man, how am I going to do this? 3 pi, 2 pi. It's going to repeat. This is 2 pi right here. It's going to look like that. That's sine of x. If I take that, you imagine that this is a piece of wire that's flexible. And I nail this point down at the origin, and I grab this point here, and I stretch it 3 times further away from the x-axis. Sorry, 3 times further away from the y-axis horizontally. Then it's going to land at 6 pi. So this thing is going to go up, down, down, up. It's going to repeat to 6 pi. So sine of 1/3 of x is what I'm going to draw in red. I split this distance up into 4 pieces. There's half. And half of each of those halves gives me 4 equal slices horizontally. It's going to go up to the maximum, down to the middle, down to the minimum, up to the middle. X is any real number. I think that goes without saying. For the range, -1 is less than or equal to y, which is less than or equal to 1. The only thing so far that can change the range would be changing the a value from 1 to some other a value, and not -1. The amplitude is 1. The period is 6 pi. But check this out. What is b? b is a third. And I've told you that the period is 2 pi, over b. Okay, what does that give us? 2 pi over a third, which is a complex fraction, and the best way at this level to clean up that fraction is to multiply the top and the bottom by any pesky denominator that you don't want to see there. And we've got that little mini 3 as a denominator, so I'm going to multiply top and bottom by 3. So what happens on the top is you get 2 pi times 3, which is 6 pi, and on the bottom you get 1, 6 pi. What I'm telling you is, I think to find periods of trigonometric functions, you do not want to think about stretches anymore. You just want to go 2 pi divided by b. So that being said, let's try this one without even graphing it. The domain is any real number. The range is -1 is less than or equal to y, which is less than or equal to 1. The amplitude is 1. The period is going to be, let's see, 2 pi over a half. 2 pi over b. So if I multiply the top and bottom of this fraction by 2, I get 4 pi. Which really makes sense, doesn't it? I hope. B is a half, which means it stretches it horizontally by a factor of 2. So your period goes from 2 pi to 4 pi. I'm not even going to graph it. Any questions with those 8 parts of example 1? They are all learning exercises so that we can say the following. When you have either of these functions, when you have y equals a sine of bx or y equals a cos of bx, the amplitude will always be determined by looking at the parameter a. And if a is negative, the amplitude is just that number. It's not the negative. So that's why I have absolute value of lowercase a. And the period is 2 pi over b. If you wanted a graph in degrees, then it would be 360 over b. You'll notice I put b as an absolute value because if b is negative, that just reflects it horizontally. It doesn't affect the period. I'm going to pause there and just see. Does anybody have any questions about any of these examples or anything that's up here? Okay, I want to point out one more thing, and it's not in your notes, but you can certainly add it. If the period is 2 pi over b, then b is 2 pi over the period. If you cross multiply here and solve for b, you get 2 pi over the period. And that's useful to know, and this is not on your formula sheet. None of this stuff is. That's useful to know in case you know the period and want to find b. So if you know b, to find the period, you take 2 pi divided by b. If you know the period and you want to find b, you take 2 pi divided by the period. Okay, so this I really think, I wish I had some candy up here that we could steal from the baby, because this is like stealing candy from a baby at this point. I hope. The domain is any real number. The range is -3 is less than or equal to y, which is less than or equal to 3. And you know what? As a teacher, I maybe made a mistake in designing this. I probably should have put amplitude first. Because when I figure out what the range is, I immediately ask, what's the amplitude? And I see up here that the amplitude, since a is 3, the amplitude is 3, which means it goes from -3 to +3. The period is pi because the period is 2 pi over b. And we look up here, you can see b is 2. So we have 2 pi over 2, which is pi. So I don't clutter my brain with stretches. I don't think about stretches here for the period. Domain, x is any real number. Range, -1/4, less than or equal to y, less than or equal to 1/4. Amplitude is 1/4. Remember, the amplitude is the absolute value of a. It's the absolute value of a. A, little a, lowercase a, is -1/4, and b is 1/2. So the amplitude is the absolute value of that a. Period is 4 pi because the period is 2 pi over b, which is 2 pi over 1/2. I'm not going to show you multiplying the top and the bottom by 2 again. We know that's what happens. It becomes 4 pi. Any questions with 2a or b? Didn't I just do that? Oh, I must have erased it. What's a sine function with an amplitude of 4 and a period of 90 degrees? So if the amplitude is 4, a is 4, that works, right? B will be 2 pi over the period. Well, actually, you know what? I lied. B will be 360 degrees over the period. I'm using the 360 degrees rather than 2 pi because it says a period is 90 degrees. How many of you, I'm just curious, how many of you see here that B is 4 just by looking at 90 degrees? Because you're going from 360 to 90, so you're stretching by a factor of 1/4, which means B is 4. But what happens is that's borne out here. We get 360 degrees over 90 degrees, we get 4. So y equals 4 sine, nope. Oh yeah, 4 sine 4x. A and B are both 4. Why did it say determine an equation? Because you could have been just that person that says, I'm going to use -4. That would be fair. That would still have an amplitude of 4 and a period of 90. Y equals 1/2 sine some number times x. That number will be 2 pi over 6 pi. It's 2 pi over the period, which is a third. I suspect there are a few of you that knew it was a third because the period is 3 times greater. By the way, I don't know if you noticed, sometimes we put brackets around this argument for sine, sometimes we don't. Doesn't matter. Any questions with 3? Right, we have one last one to do. If this is a cosine function, what's the equation of the function? So this is no different than the previous example. We just have to pull a and b off of the graph. So one thing I notice here is that the maximum value is 3. The minimum value is -3. The middle is 0. So that I need an amplitude of 3, right? The amplitude is 3. What's the period? Well, I just have to read this off of the graph. It's 4 complete pieces. There's 1. There's 2. That was going to happen. There's 2. There's 3. And there's 4. So it repeats in pi radians. The period is pi. If the period is pi, b can be found by taking 2 pi over the period, and you get b is 2. And again, I'm aware there's a whole host of you out there that you don't need to write that out to figure out that b is 2. Okay. And if the amplitude is 3, then we use a equals 3, and a student would write, well, then a equals 3 cos 2x, because they think, oh, this is simple, but there's a tiny wrinkle here. This is wrong. If you were to graph that on your graphing calculator, it will not give you that picture. What's the problem here? What's the issue? Evan? Right. Cosine has, we're going to end up calling this a start point. For cosine, the start point is always at the top and it goes down. But this graph doesn't start at the top going down. If we reflect it vertically, though, we can say it will start at the bottom going up. So a is, in fact, -3. Whoops. The amplitude is still 3, but we need to say that little a is -3. This is it. If you can look at this function and tell me that the amplitude is 1/2, that the period is 2 pi over 3. I'm curious, Evan, when you figure out the periods, can you do it with this one too, the way you're doing it? And what I think what you're doing, just to let everybody else know, and there's a few other people that are doing this, you're saying it squishes it this way by a factor of 1/3, so it's 2 pi over 3. Okay. The range is -1/2 to 1/2. The domain is any real number. These are things that you should know just by looking at that. So the summary of this, what we learned, is a page that I deleted. Nope, is there. And you can see what the assignment is. Lots of problems that you can practice for Monday. Monday, all we're going to do is we're going to say, well, what happens if we start shifting these guys around? We introduce an h and a k, which, by the way, we don't call h and k in trig. We call them c and d, but we're still going to shift things. Okay. Then we will be done the unit. We'll review on Tuesday and Wednesday, and then your exam is Thursday. So everybody get started. I will get around and help you out as soon as I take care of a couple of things.